In this tutorial, simple sketch geometry will be produced to create a profile. The profile will be extruded bidirectionally about the workplane, subtracting the inner regions. Modelling features will be applied to the surfaces and edges of the solid. The bearing shown assembled in the model will be inserted from the blocks palette. The sample drawing for this task contains blocks of the sketch geometry and the finished model. Both parts can be inserted into the editor at any stage of your design. A block has also been created of the bearing and saved in the sample drawing. (2D) sketch geometry, such as simple lines and circles, is useful when constructing a 3D model. It provides useful geometry for building and assembling the parts of the model. It also provides a 2D sketch for dimensioning purposes at the completion of the drawing. Frequently, sketch geometry forms the foundation of the 3D model, allowing a profile to be extruded bidirectionally to produce a solid model. Modification features such as edge blending can be used to create transitional surfaces on multiple edges. Surface modelling can be performed, such as applying downward pressure on the facet of a solid. Sketch geometry can be retained during the design process and performs a useful function for assembling additional parts. For example, the center point of the circle can be used to assemble the bearing. For this 10-minute task, the view is set to World Plan. The display mode is set to Wireframe. Right-click in the editor to find these display tools. Use the Single Line tool to draw two straight intersecting lines in the editor. Make the vertical line approximately 90 and the horizontal line approximately 75 using the Shift key to draw straight lines. These line lengths are approximate and can be adjusted later. The Parallel tool is used to offset the horizontal line at a distance of 25. Two concentric circles will now be inserted onto the bottom intersection. In this example, the snap modes are deactivated and the single entry keyboard equivalents will be used. The keyboard shortcut I will be used to target the intersection here. To insert the concentric circles onto the intersection, position the cursor over this intersection and input the keyboard shortcut I. The keyboard tab key is used to access the data fields to input the diameter values. A single circle will be inserted onto the top intersection using the same method. These circles will be arrayed around a center point to create a total of 3 sets of concentric circles. This intersection here will be used as the center of the array. This intersection must be specifically targeted for this task. Both circles will be selected, then the radial tool will be used. Use either the keyboard input I to target the intersection or C to target the center of the circle. Tab to the data fields and input the following values. To create the arcs which connect the outer circles, a circle will be drawn tangentially to these 2 circles. The new circle will create tangency between the outer circles in order to create an arc. The new tangential circles can now be trimmed to create arcs which connect the outer circles. The Object Trim tool is used to select multiple objects as cutting edges. To isolate objects for the creation of a 3D solid, the center lines can be moved to their own layer. At the completion of the 2D drawing, a block can be created of your sketch. By selecting the option to insert at current location, the new block is retained in the editor so you can continue your drawing. To prepare the sketch for 3D creation, first make sure that the sketch is exploded if it's been returned from the blocks palette. Unused elements such as dimensions and center lines can be deleted. By displaying the work plane and turning the view to isometric southeast, it can be observed that the profile objects and the work plane lie in the same plane. A bidirectional extrusion will be created from the profile, subtracting the inner regions. This is produced by using the simple extrude tool. In this example, the profile is extruded to a bidirectional height of 3. A similar process is used to extrude the inner circle. In order to apply pressure on the face of a solid object, the model must be formatted as a solid. Select the Pressure Load tool, then tab to the data fields and input the following information. Select the top face of the cylinder, making sure a downward pressure is applied. The outer edges will be blended using a curvature continuous blend. Repeat this to create a separate blend on the top edge of the cylinder. Objects can be hidden or isolated in the editor for specific tasks. For example, by hiding the extrusion parts, only the sketch geometry will be displayed in the editor. For example, by revealing only the sketch geometry, the centre of the circle can be used as a convenient assembly point for the bearing. The Hide or Isolate Objects feature is available from TurboCAD version 2019 onwards. It provides a convenient method of isolating or hiding an object without using the design director's layer control. In this example, both of the solid objects will be selected. The Hide Objects option is selected, thereby displaying only the sketch geometry in the editor. The two parts will remain hidden until the isolation is ended. The bearing in the blocks palette will now be inserted using the center point of a circle. The part from the blocks palette will be inserted in transit, so the center snap must be activated. Insert the bearing from the blocks palette using the center point of any of the circles. Parts which are inserted from the blocks palette can be inserted in any view. When the bearing has been inserted into the sketch, the End Isolation tool is used to reveal the hidden parts.